Good day, ladies and gents. Welcome to BK Mathematics. And if this is your first time of you coming across this channel, please make sure you share, comment, like, for the mathematics community. Okay? And I'm here with my students also, and I'm going to prove or to show that y sine square theta plus cos square theta is equal to 1, and he's going to solve this problem based on the same subtopic. Okay? Now I'm going to start with it to prove. Now the question says, show that sine square theta plus cos square theta is equal to 1. How? Just watch to the end. Now we are going to provide a solution to it. Now the first step from this, we are going to draw our right angle triangle. Draw your right angle triangle like this. This is our right angle triangle. Okay, this is our 90 degree. This is the angle that we are giving. Now from this, you can say let this the opposite part be A, this is C, and this is B. Okay, now from this, we are going to say, remember for sine, we know sine theta, it is equal to opposite upon the hypotenuse. Okay, then for cos, we say for cos theta, it is adjacent upon the hypotenuse. From supersquare method. Now, if you want to find sine theta from this, we know this becomes sine theta. What is the opposite from this part? It is A. We say A divided by what is the adjacent, what is the hypotenuse? It is C. Similarly, for cos, if you want to find cos, what is the adjacent part? It is B. We say B divided by. Then what is the hypotenuse? It is C. Now, the question says, sine square theta plus cos square theta is equal to 1. Now we are about to prove or to show. Now for sine we have A. You can say we call that for sine we have A upon C raised to the power 2 plus. Then for cos we have B upon C raised to the power 2, and everything becomes 1. Now we are going to apply Popular law of indices, we distribute this power over its factor, okay? Meaning this is A square divided by C square plus B square divided by C square. Okay, this equals 1. Now from this, we are going to find our LCM. Then our LCM becomes C square. Then, we know C square into C square is 1 times 1 multiplied by A square, it is A square plus. The same thing applies. C square to C square is 1 times B square given B square. This equals 1. Okay, now from this we are going to say A square plus B square equals C square times square is C square. Okay, now from Pythagoras theorem, if we apply Pythagoras theorem from this point, we know that this is hypotenuse. We say C square is equals, just like whenever you are solving problems on Pythagoras, the square this, the sum of the square of this side must be equal to the sum of the square of the two other sides. That is, this square is equal to A square plus B square. So now for the fact that this C square is equal to the sum of the two other sides, so therefore you can say C square from this point, C square is equal to A square plus B square respectively. So from this point, we already shown that sine square theta plus cos square theta is equals 1. Okay? Or if you want, you can still leave it like this, or you divide also. That's the same thing as we have. Meaning, you know, A square plus B square, then divided by, then C square, you know, you only have limits from Pythagoras theorem that A square plus B square. Then, you know, if you divide this one, automatically you're going to have 1 equals 1. So this is what it means. We have already shown that this trig ratio is equal to 1 respectively.
Alright guys, from the board you can say a question like this. If sine theta is equal to k, now we are asked to find tan theta. Now from the three trigonometric ratios, when you're asked to find tan theta, that simply means that you cover the hypotenuse. So now, this solution, since this is the question, sine theta is equal to k. but we remind you, if you also divide it by 1, it is the same. Now from this point, this is the opposite and 1 is the hypotenuse. Now if you are to represent this information in a right angle triangle, this simply means this is the angle of consideration theta. The angle of consideration is opposite to K, and the hypotenuse is 1. So this is x, and x is the adjacent. So now let us use Pythagoras theorem to find the value of x. Now, if you use the Pythagoras theorem, remind you, according to the Pythagoras theorem, the law states that the longest side, that is the hypotenuse, is equal to these two guys. So in sense, this has to be 1 square is equal k square plus x square. So now in this case, since we are going to find the value of x, that simply means this k square has to move to this side. So 1 square minus k square is equal x square, but 1 square is the same as 1. 1 minus k square is equal x square. But in this case, we are not asked to find x square, we are asked to find x, and x represents the adjacent. So since this is the question, this is the point, x square is equal 1 minus k square. Now you square root both sides. The square root cancel the square, and what remains is x is equal 1 minus k square, all in root. But now, since we've got the value of x, and x is the adjacent, now, but we are asked to find tan theta, that is the hypotenuse. So from this end, we are going to apply the formula which says tan theta, that is the hypotenuse, is equal to the opposite divided by the adjacent. But now from the equation, you find the adjacent, and the opposite is what? K. So now this has to be tan theta is equal. What is the opposite from the angle? It is K, right? Divided by the adjacent. The adjacent is the square root of 1 minus k square. So automatically this has to be tan theta is equal k divided by the square root of 1 minus k square as required.
So that is it, and thank you for watching. Make sure you share, comment, like, also give us a comment, more.